Imagine you're on a raft, floating down a calm, dark river. Suddenly, you notice the current is picking up speed. You aren't paddling, nothing is pushing you from behind, but you're accelerating. You look around, but the riverbanks are too far away to see. The water is an inky black. Yet, you feel an undeniable, relentless pull toward a single point just over the horizon. Now, scale that up. Your raft is our Milky Way galaxy, with its 400 billion stars. The river is the fabric of spacetime. And that unseen pull, it's dragging us and 100,000 other nearby galaxies at a staggering speed of over 2 million kilometers per hour towards an unknown destination. Astronomers have a name for this invisible cosmic behemoth, the Great Attractor. It is one of the most profound and unsettling mysteries in modern cosmology, a gravitational anomaly so massive it is bending a vast section of the universe around it, and we are caught in its grip. The story of its discovery begins not by looking for something, but by noticing that our cosmic neighborhood was behaving very strangely. In the 1970s, astronomers were studying the cosmic microwave background, or CMB. This is the faint, leftover radiation from the Big Bang, and it fills all of space. It should be almost perfectly uniform in temperature everywhere we look, but it wasn't. They found a distinct pattern. The CMB was slightly warmer in one direction of the sky and slightly cooler in the opposite direction. This is a classic Doppler effect, the same reason an ambulance siren sounds higher-pitched as it comes towards you and lower as it moves away. This told us something incredible. Our entire galaxy is moving through space relative to the CMB. But this wasn't just the random drift of a single galaxy. When astronomers began mapping the motions of other galaxies in our local group and beyond, they found the same thing. Everyone was going to the same party. Instead of all galaxies moving smoothly away from each other as the universe expands, which is what Hubble's law predicts, there was a huge, coordinated flow. Galaxies across a region of space hundreds of millions of light-years across were all streaming towards the same point in the sky, located somewhere behind the constellations of Triangulum Austral and Norma. The math was undeniable. To exert that kind of gravitational pull on so many galaxies, including our own, this great attractor had to have the mass of tens of thousands of Milky Ways. It had to be a concentration of matter on a scale almost too vast to comprehend. So the next logical step was to point our best telescopes at that spot in the sky and see what was there. And that's when astronomers hit a wall made of our own galaxy. The Great Attractor is located directly behind the plane of the Milky Way. This region, known as the Zone of Avoidance, is so densely packed with our own stars, gas, and interstellar dust that it completely blocks our view of the distant universe behind it. It's like trying to watch a ship on the horizon while standing in the middle of a thick, blinding fog. Visible light simply can't get through. For decades, the source of this immense gravitational pull remained a complete phantom, its existence known only by the pull it exerts on us. Slowly, with new technologies, we began to peel back the veil. Using telescopes that can detect infrared and X-ray light, which can penetrate the dust more effectively, astronomers started to map this hidden region. They found what they were looking for, sort of. In the heart of the region lies the Norma Cluster, a massive cluster of galaxies. It's huge, but it's not huge enough. The Norma Cluster can only account for a fraction of the total gravitational pull that we measure. The Great Attractor wasn't a single object, but a more diffuse, spread-out concentration of mass. The picture got even bigger and stranger when we zoomed out. Astronomers realized that the Great Attractor itself is just the center of a much, much larger structure. In 2014, they defined the boundaries of our home supercluster, a colossal web of galaxies they named Laniakea, which means immeasurable heaven in Hawaiian. Laniakea contains 100,000 galaxies, stretched across 520 million light-years. And in this context, the Great Attractor isn't some mysterious monster. It's simply the gravitational focal point, the bottom of the largest valley in our local supercluster, and all the galaxies within Laniakea, including our own Milky Way, are flowing downhill towards it. But the mystery doesn't even end there. When we look beyond the Great Attractor, even further behind the zone of avoidance, we see something else: the Shapley supercluster. It is an even more enormous concentration of galaxies, the largest in our local universe. Many astronomers now believe that what we call the Great Attractor is just the nearest gravitational well, but the overall pull we feel is a cosmic tug-of-war between the Great Attractor and the even more massive Shapley supercluster beyond it. We live in a dynamic, flowing universe, far from the static cosmos we once imagined. We are not just drifting, we are on a journey. Our galaxy is part of a grand cosmic river, flowing along filaments of dark matter, pulled towards basins of immense gravity that we are only just beginning to chart. The Great Attractor is no longer a monster hiding in the dark, but a signpost showing us our place in the cosmic web and the direction of our collective voyage. And so we hurtle through the darkness, passengers on a cosmic river flowing towards an unseen gravitational heart we are only just beginning to map.